700 million years ago, our planet was a completely different place. No trees, no flowers, no animals you know today. The entire Earth was covered in ice, like a giant snowball floating in space. Scientists call this Snowball Earth, and it was the coldest period our planet has ever experienced. But then something incredible happened. In the middle of all this ice and extreme cold, life found a way. Strange creatures, unlike anything that exists today, began to appear in the melting oceans. They were Earth's first animals, without eyes, without mouths as we know them. Some looked like leaves, others like air mattresses floating in the water. How did life manage to survive the worst winter of all time and create our planet's first animals? Subscribe to the channel, leave your like and comment from which part of the world you're watching, because now I'm going to tell you everything. Have you ever wondered what the world looked like before there were trees, flowers, or even grass? Picture a time when everything as far as you could see was frozen and covered in white. Our story begins during one of the coldest times the Earth has ever known, about 700 million years ago. This time is called Snowball Earth, and it was not just a long winter. The whole world, land, sea, and even the sky, became colder than anything people have ever felt. Back then, the sun still shined, but most of its light did not warm the ground. Instead, the light hit thick sheets of ice and bounced back into space. Day after day, the ice became thicker, and the cold air never went away. There were no green trees, no small plants, and no moss on the rocks. There was only endless ice, spreading from the north to the south and from the east to the west. Even at the equator, the part of the Earth that is closest to the sun and usually warmest, the ground was hard and white with thick ice. It was quiet, so quiet that it almost felt like the world had stopped. No birds called out, because there were no birds. No wind rustled in the leaves, because there were no leaves. It was a world without the sounds we know today. The only noises came from the creaking of the ice, the slow cracking as it pressed against itself, and the faint whistling of a dry, sharp wind. The sky was often gray or white, mixing with the frozen land below so that everything looked the same everywhere. Rain did not fall. Rivers did not flow. Lakes were not filled with water, but with ice so hard and clear that it was almost like glass. The oceans, which today are full of life and color, were covered with an unbroken layer of ice. Under this thick cover, the water was still and cold. On top of the ice, there was nothing at all. The world was silent, empty, and asleep under a heavy blanket of snow. No animals lived on the land. There were no insects, no worms, not even the smallest beetle crawling in the dirt. There were also no people, because people would not appear for hundreds of millions of years. The land was just hard, cold rock and ice that went on and on. There were no colors but the white and gray of snow and the dark blue of the sky when there were no clouds. At night, the world froze even harder, and the stars watched over a world where almost nothing moved. Imagine what it would feel like to walk in this world. Your footsteps would crunch on the ice, but if you stopped, you would hear nothing. The air would burn your lungs with cold. If you looked around, you would see nothing but wide flat plains of snow, with the hills and mountains hidden under thick layers of shining ice. The only sign of change would be the slow work of ice and snow piling up, never melting, just getting deeper with each passing year. In this world, the ocean was different too. Normally, the ocean is a busy place, full of swimming animals and growing plants. In Snowball Earth, a thick cap of ice covered nearly every part of it. The ice stretched for many miles, making it impossible for sunlight to shine through to the water below. With no sunlight, the upper layers of the ocean became dark and silent, just like the land above. The air was not just cold, but very dry. Today, snow falls in winter, but back then, The cold was so complete that there was little moisture left to form snow or rain. The wind sometimes blew hard, picking up sharp pieces of ice and sending them across the frozen surface. These were not gentle breezes or light flurries. These were strong, cutting winds, moving across a dead, lifeless landscape. Because the ice was so bright, almost all the light from the sun bounced off its surface. When you wear a white shirt in summer, it can feel a little cooler because the sunlight does not soak in. The same thing happened across all of Snowball Earth, but much, much more. The white ice reflected nearly all the warmth back into space, keeping the Earth locked in deep cold. There was almost no way for the planet to warm up again. But how did it all begin? Long before Snowball Earth, our planet was actually warmer. It had no forests and no grass, but there was simple life living mostly in the ocean. These living things were not animals or plants as we know them. They were tiny creatures, much smaller than any animal you can see. Each one was made of just a single cell. These cells floated in the water and lived simple lives, eating chemicals from the sea and making more cells, one after the other. Over many millions of years, these tiny forms spread through the oceans. Then something changed. The world's climate shifted, and the air began to cool. Slowly, the temperature dropped, and the first snow started to fall. At first, the snow came only in certain places. But as time passed, the cold grew stronger and the snow and ice spread farther and farther. The oceans began to freeze at the surface. The land was covered with snow that did not melt in the warm months, because there were no warm months anymore. As the cold continued to grow, the living things in the ocean faced a great problem. The ice made it hard for sunlight to reach them. Without sunlight, they could not make food in the ways they once did. Many of these tiny creatures died because they could not survive without light and warmth. The lucky ones found special places deep under the ice, close to the bottom of the ocean, where it was a little warmer. On the land, nothing survived. There were no living things on the frozen ground, and no green plants to turn the sunlight into food. For millions and millions of years, the land stayed empty. The cold lasted for a very long time. It was not just 1 or 2 years, but millions upon millions of years. For a child, waiting for 1 year can feel very long. Imagine waiting for 100,000 times more than that, with no change in the cold, frozen world. During all this time, the ice grew thicker and deeper. Sometimes new snow fell in huge storms, adding more and more weight to the icy surface. It is hard to think about how different this world was from the one we live in today. Our world is full of trees, flowers, and animals. Water moves in rivers. Birds fly in the sky. But for millions of years, none of these things existed. There was only ice and quiet. If you could see this world from space, it would look like a big snowball floating through the dark. There would be almost no colors, just the shining white of the ice and the blackness of the sky. Planets around other stars might look similar if they are also covered in thick ice and snow. In this world, there was no food chain or web of life. There were not even any plants or animals to start such a chain. The only places where life continued were deep below the ice, protected from the deadly cold above. Even here, life was slow and close to stopping. Living things grew and changed much more slowly than they do today, because there was very little food and almost no warmth. All around, there were signs of the great power of ice. Mountains were ground down under huge rivers of moving ice. Valleys were carved deeper as the ice forced its way forward, crushing rocks beneath it. The land was shaped and changed, even though there were no people or animals to see it happen. Sometimes, scientists today find scratches and marks on old rocks that show where these great ice sheets once moved. The land we live on now still carries the memory of Snowball Earth in its rocks and valleys. There were also strange storms during Snowball Earth. These were not rainstorms or thunderstorms. They were storms of ice, where the wind blew sharp, cold crystals across the land. Sometimes the sky was filled with gray clouds made from tiny bits of ice moving high above the ground. The sun, when it could be seen, looked pale and far away, giving little warmth. At night, the world grew even colder as the icy ground gave off the tiny bit of heat it had saved during the day. With so much of the world frozen, even the air changed. Today, our air holds water that comes down as rain or snow. But in that time, the air became very dry, because most water was locked in the ice. Without water, the clouds were thin, and snow stopped falling in many places. The world became not just cold, but dry and empty. In the rare places where the ice was thin or broken, strange things happened. Sometimes great cracks would open in the ice, and deep black water could be seen below. But these cracks closed quickly as more ice formed to cover them up. Nothing lived on the ice itself. There were no penguins, no seals. Not even the smallest living thing could survive the sharp, dry air and the never-ending cold. Under the thick ice, the ocean still moved very slowly. Far down, close to the heart of the planet, some heat from deep inside the earth kept small parts of the water from freezing. In these shadowy places, life clung on. Here, tiny living things did not need sunlight. Some used chemicals coming from the rocks to survive, turning them into food in complete darkness. But all this was far below the world of endless white above. On land and at the top of the oceans, everything was silent and still. The snow and ice smoothed out all the hills and valleys, making the world look flat and empty. No one knows just how thick the ice became, but it may have been as tall as a mountain in some places. This was not an Earth we would recognize today. It was a world where nature had fallen asleep under a heavy, icy blanket. For millions and millions of years, this was how the Earth remained, locked in cold, quiet, and darkness. But even in these hardest times, something was happening deep below the ice. Life was changing slowly and quietly, hidden from the frozen world above. Tiny living things that had once filled the ocean during warmer times were now forced to find new ways to survive. Some did, holding on in the few places that still had warmth deep beneath the surface. Though the cold and silence went on for so long, the deep parts of the ocean became a place where the story of life would soon begin a new chapter. This frozen world, so calm and still on the outside, would prepare the way for living things to slowly grow and change, for life to find a path out of the darkness and into the world we know today. Deep inside the darkness, under the thick ice, small living things waited. The world above was silent and white, but far below, in the cold water, life was still holding on. Everything was very different from the land on top, which was empty and frozen. The water here was dark and cold, but not still. The Earth's heat deep under the ocean floor kept some places just warm enough for some special creatures to stay alive. Long before all this ice and snow covered everything, the Earth was a different place. The ocean was large and wide, and it covered most of the planet. There were no trees and no grass, but there was life. The first living things were very, very small. You could not see them with your eyes. Even if you looked closely at the water, you would only see the waves, not these tiny creatures. Each one was made from only a single cell. These small creatures are called microbes. They did not have arms, legs, or even a mouth. They were the first life on Earth, and they lived mostly in the ocean. These microbes were everywhere in the water. They could float near the top of the sea where they got a little sunlight. In warmer times, these tiny cells did many things. Some used sunlight to make their own food from simple things in the water. Others ate small, simple food around them. Some microbes could make the water look green or blue when they grew in big numbers. It was a simple, quiet world, but it was full of life in the ocean. On the land, life could not grow. The ground was bare and empty, made from rocks and dust. The sun was bright, but there was no air that plants could use to make food. So all the life stayed in the water. Sometimes the wind would blow dust into the ocean, and the microbes used parts of this dust to help them live. Every day, billions of microbes floated, ate, and made new copies of themselves. They did not look like anything we see today, but they were alive and busy. There was no winter or summer like we have now. The weather was mostly warm, and the ocean was calm. Days passed, and these tiny creatures filled the water. Over many millions of years, they slowly changed in small ways. This is because from the very beginning, all life on Earth was changing bit by bit. When a microbe made a new copy of itself, sometimes it was a little different. Some of these differences helped the microbe live better. Others did not help, and those microbes would not last long. The small changes that helped the microbes were passed to new copies, and life in the ocean very slowly became stronger. This long, slow change is called evolution. It is not fast. Each tiny step happens over hundreds, thousands, or even millions of years. But step by step, the world of microbes became more interesting. Some became better at finding food. Others became better at using sunlight. Some learned to live with other cells to help each other survive. In this way, life was always changing, but always very slowly. In those days, Earth's oceans were not too salty and not too cold. Most of the time, the simple cells could find what they needed to live. Some groups of microbes made small bubbles of waste, and these bubbles started to add gas to the air above the water. This was the first time the sky had any oxygen. It was not much, just a small bit, but it would help life in the future. Other microbes could survive in places where there was no air at all. Some lived deep in the water. Others lived near places where hot water came out of the ocean floor. These places had strange chemicals, and the microbes here learned how to use the chemicals for food. They were different from those that lived near the sunlight. The ocean was big and full of many tiny forms of life, each with its own small way to survive. As more time passed, some microbes started to live together in big mats, like soft blankets lying on the bottom of the ocean. These mats were made from many, many microbes, all growing next to each other. They covered the rocks and sand under the shallow sea. In these places, microbes shared food and kept each other safe. The mats made strange shapes and patterns. When the water moved, the mats could break and float away, spreading microbes to new places. Other microbes began to join together to form chains or small groups. Most were still very simple, but sometimes living in a group helped them survive. A group could stay in one place if the water was moving too fast, or if there was not enough food. When living things work together, they sometimes become stronger than if they were alone. During this time, the Earth's surface changed slowly. Volcanoes sometimes brought new rocks and dust into the ocean, and the rain would fall on the bare land and carry it to the sea. There were tides caused by the pull of the moon that moved water in and out, bringing new food and changing the shape of the shore. Sometimes the ocean was a little warmer, sometimes a little cooler. But nothing was ever as cold as the time when everything froze. Then, slowly, the world began to change. The air in some places started to get cooler. Some of the heat from the sun did not reach the ground. Cold winds moved over the land and water, and the first pieces of ice and snow began to appear at the tops of mountains. At first, the ice melted away in warmer days, but then it started to last longer and spread. The cold came from far away, but it moved closer and closer every year. When the cold became very strong, the oceans began to freeze at their edges. For microbes in the ocean, life became harder. The layer of ice on the water blocked away much of the sunlight. Without sunlight, some microbes could not make their food. Many of them died. The cold went deeper, freezing more of the ocean. The floating mats of microbes broke apart as ice covered them. The chains or groups of cells could no longer float free. They became trapped under ice or crushed by snow as it fell into the water. But some microbes managed to find safe places. At the bottom of the ocean, where the Earth's heat still warmed the rocks, small cracks let out energy and strange chemicals. This was enough for a few special microbes to live. They did not need sunlight or air for their food, only the heat and chemicals. These tiny creatures kept growing, even as the rest of the ocean above became too dark and cold for life. Above the ice, the world became empty and quiet. The land was covered with snow and ice, and there was no color or sound. The ocean, which once had so many small forms of life, now had only a few left in hidden places. Life seemed to stop, but deep down it continued in the darkness. Even as the cold pressed down from above, some microbes in the deepest water started to grow in new ways. Instead of living alone, some started to stick together more closely, 2 or 3 cells, then a few more, then sometimes many. These little groups could protect each other and share food. If one cell found something useful, all the cells would benefit. This was the beginning of living things working together in a new way. Soon, these groups began to do things no single cell could do. They cleaned waste more quickly, they could store food, and if the water became too dirty or cold in one place, the group could move together, little by little, to a safer spot. Sometimes a cell would be hurt by the cold or by sharp things in the water. The others could help it, or the group could make new cells to replace the ones that were lost. This made these groups of cells stronger and more able to survive. Some groups of cells grew in flat layers, sticking to the ocean floor. Others formed balls or tubes. These simple shapes are the first step toward more complex life. Sometimes the shapes were very soft and the cells could change places with each other. Other times the cells stayed in one part, doing the same job all their lives. One cell might collect food, another might move the group, and another might keep waste away. The cold world above did not know anything about these quiet changes happening in the water below the ice. Storms moved over the ice, but in the deep water, the new groups of cells carried on their slow work. They made copies of themselves, and each time they did, small changes could happen. Some groups became a little better at surviving. Slow steps, taken one by one, helped life make it through even the darkest days. The way life slowly changed in the deep ocean was the start of something new on Earth. Even though the thick layers of ice made the world seem dead, the quiet, steady work of all those tiny groups of cells would become the beginning of bigger and more interesting living things. Time moved forward, counting not in days or months, but in millions of years. Generations of microbes came and went. The frozen world outside did not change for a very long time. Still, small changes added up, and life kept finding new ways to exist, even in the hardest conditions. Some of these changes made the groups of cells more organized. Instead of moving anywhere inside the group, some cells now did special jobs. One kind of cell would help the group find food, while another kind protected the group, and another kind took care of waste. Special jobs helped the whole group survive together as one. Sometimes a group of cells split into 2, and each part would start a new life. If one of these new parts had a better way to survive, it would soon become more common in the ocean. If not, it would fade away. Over a very long time, these groups became the first forms of multicellular life. They were still soft and small. They did not have eyes or mouths or legs. But they could do more than single cells ever could. They shared food, protected each other, and found ways to live where the cold and ice had pushed everything else away. Some groups stuck tight to the sea floor, near the warm cracks on the ocean bottom. Others floated just beneath the thick ice, living off whatever food they could find. The dark water became a quiet home for these new forms. There were no fast movements, no hunting and no bright colors, only slow, simple life holding on under the ice. The world outside changed, only very slowly. More ice formed, and the snow grew deeper every year. Storms came and went, but the quiet, deep ocean stayed the same for a long, long time. Some days, the only difference was the small changes made by the living things below. With each new group, each new small step, life was getting ready for something bigger. It would take many more millions of years for these groups of cells to become what we think of as animals. But even now, this was the start. The lessons learned in this cold, dark time would help life become stronger and more able to survive in the future. All this happened long before there were any plants or animals with bodies we know. Trees, flowers, and grass would come much later. For now, the story of life was written by tiny cells, working together, slowly, quietly, deep under the ice, waiting through the longest, coldest winter the world has ever seen. Inside the cold ocean, far below the thick sheets of ice, the gentle work of tiny living things continued. The earth above stayed deeply frozen and empty, and the seas stayed dark most of the time, with sunlight unable to pass through the heavy lids of ice. Here, in the deepest parts, the air and water were colder than almost anything living today could survive. Life in this quiet darkness moved forward by only the smallest steps, but those steps were important. For a very long time, the biggest challenge was the extreme cold. In places near the ocean floor, the water stayed just warm enough for small groups of cells to go on living. Every day and every night, which were both very dark under the ice, these tiny living things searched for food and tried to stay alive. There was very little food to find. The cold made it hard for new living things to grow. If a group happened to settle near a crack in the ocean floor, where warm water and chemicals rose up, it had a better chance to grow. But if the group floated away from these special places, life often stopped. Not only was the cold a problem, but the lack of sunlight made everything harder. Water above the ocean floor was covered by very thick ice. The ice blocked almost all the sun's rays. Today, many living things in the sea depend on sunlight to make their own food. Back then, these first groups of cells could not use much light, so they needed to find another way to survive. They slowly learned to use energy from certain chemicals that came out of the ground. This way of getting energy is very ancient and simple. The water also held very little oxygen, which is something almost all large living things need to breathe. Long ago, before snow and ice covered everything, some microbes in the ocean made oxygen as waste. But as the world grew colder and the ice became thicker, the amount of oxygen in the water dropped again. Groups of cells had to find ways to live with only a tiny bit of oxygen or in places where there was none at all. Some learned to live off only chemical energy, which did not need any oxygen. The winds above the ice were strong and dry. When they blew, they sometimes picked up particles of dust from the empty land. These dust particles settled on top of the ice or slowly reached the water through cracks or tiny holes. Sometimes these bits of dust carried things that the microbes could use, like simple minerals to help them make food. Even so, life was always on the edge, using whatever it could find, changing slowly over many years. Ice storms were common in this age. The air was often filled with sharp, frozen crystals. Storms would pass over the land and drive snow and ice across the surface. The pressure on the ice sheet would grow, making the ice even thicker. Sometimes the ice sheet cracked and stretched. Now and then, a small opening formed, but it always closed up quickly. Any living things that floated close to the top would be caught in the freeze and would not survive. Each year, the ice above became heavier. The weight of the snow and the weight of new layers pressed down on the older ice below. The ice became so hard and thick that sunlight would never get through. The world above stayed silent and almost lifeless. Animals and plants were still far in the future. All life that remained had to deal with darkness, cold, and very little food. Groups of cells living near the bottom of the ocean changed as best they could. They made use of the warm water currents that came from the inside of the earth. Some lived together in mats, covering the ground like a soft coating. These mats could survive where the water was a little warmer. The life living there was slow, but being together in a group helped them last longer. Where the cracks in the ocean floor let out bursts of hot water and chemicals, special places called hydrothermal vents were formed. The water here was full of unusual chemicals that normal living things cannot use. But some groups of cells learned to get energy from these chemicals. They turned them into food using simple processes inside their cells. These special living things are called chemosynthetic because they make food from chemicals, not from light. The hydrothermal vents became the main home for most life during this frozen time. Large numbers of tiny cells gathered there to survive. Some of these microbes attached themselves to rocks near the warm water. Some floated gently in the warm flow. Sometimes groups of cells would form bigger masses, helping each other to use the limited food. There was no bright color under the sea at this time, only simple groups of tiny living things holding on. Living next to the hydrothermal vents was not easy. The water was hot in some places and very cold only a short distance away. Sometimes the chemicals poured out too quickly and changed the water, making it harder for some cells to live. The water had little oxygen, so only the living things that did not need much could stay. Although most life was quiet, sometimes the ocean floor would move. Earthquakes and volcanoes happening deep under the sea opened new cracks and closed old ones. When this happened, some life was lost, but these changes also made new places for life to start again. Each time a new vent opened, new groups of cells gathered to make use of the chemicals and the warmth, starting a new home. Near the hydrothermal vents, some of the more complex groups of cells grew slowly into even more interesting forms. Life, through slow change, began to organize itself in new ways. Some groups could protect themselves better from the cold, while others learned to grow stronger walls around their bodies. Some groups grew larger, joining more cells together to make use of the food and warmth. All of this happened in quiet darkness, cut off from the world above by thick layers of ice. Nothing from the surface reached these living things. Still, life continued, step by step. Elsewhere, deep under the thick ocean ice but far from the hydrothermal vents, life was even harder. There was almost no warmth at all, and only a small amount of chemicals for food. Some microbes and groups of cells tried to live here, but only the strongest or most patient could survive. Sometimes a current would carry a bit of food or a drop of warmer water, helping a group to last a little longer. But for most, life was always in danger of ending. Because food and warmth were so hard to find, not many living things could grow bigger or change quickly. Most stayed small, and change took a very long time. Some microbes shared resources, passing simple food from one to another before it ran out. This helped the group to live even when the supply was low. While day after day passed without change above the ice, in these hidden places deep in the ocean, tiny steps in the history of life added up. When a group of cells found a better way to get food or survive the cold, they slowly became more common. Those who could not change or find food would disappear, making space for stronger or more clever living things. The harshness of this time made every new step important. With little warmth and almost no sunlight, new forms of life could only come slowly and only in special places. Life had to be tough, slow, and careful. In some rare moments, the ice above would move or break, letting a small amount of light or air through. Sometimes this gave a short chance to change, but for the most part, life under the ice was always dark, always cold. These brief openings closed quickly, and most life continued in the silence. The Earth's days and nights went by, marked only by tiny changes in the water deep below the ice. In the darkness, life kept to its slow routine, searching for food, using the simplest energy, sharing resources, and passing on new ways to survive. Sometimes, the cold was broken by small amounts of heat coming up from deep inside the Earth. This heat made a few areas of the ocean floor a bit warmer, and here, more living things could gather. These places became the centers where quiet progress happened. It was not quick or loud, but over millions of years, living things learned and grew. Chemical changes also happened in the ocean. As the microbes and groups of cells used up chemicals, they changed the water around them. Small amounts of oxygen sometimes built up for a short time, helping new ways of life to form. These times did not last long, but each helped life take another step toward being more complex. Wherever the smallest bit of energy could be found, life tried to use it. The work of millions and millions of tiny living things made tiny changes that, together over many years, allowed new groups and new forms to appear. Some cells learned to build strong structures inside themselves, helping protect their group. Others learned to join tightly and work as one, making it easier to survive when food was very hard to find. Through all these hard times, life changed very, very slowly. Changes that work in one time and place would sometimes not work elsewhere, so the only living things that survived were those that could last through the cold, darkness, and sometimes lack of food. Most of the world through all these years was silent, frozen, and still. Above the ice, the sky was gray and white, the air dry, and almost nothing moved. But hidden under the thick ocean ice, groups of simple cells never stopped working to survive. These simple forms of life, living as individuals or in groups, were all that existed for millions and millions of years. Animals, plants, and any living thing with special body parts would only appear far later. For now, the ocean's deep darkness was home to the slow, quiet growth of tiny groups of cells. While most of the ocean was covered in darkness, a few living things still found ways to grow together and become stronger. Some learned to attach tightly to rocks so they would not be moved by water currents. Some spread out in thin colonies, covering more ground and sharing what little food was available. This worked best where the water was warm or there were more chemicals. Over a very long time, these small differences helped some groups of cells to last longer and pass on their way of living. If one group was better at surviving, its way of life became more common. Every new step was shaped by the hard and silent world outside. Even in the harshest places, life sometimes had small successes. Now and then, a group of cells would split into two, and both parts would live. In lucky times, both would keep growing, helping life spread a little more. Even though many groups ended, the few that made it kept life going forward. Sometimes the ocean floors changed shape, opening new cracks or hills. These places gave life a new chance to spread. If a group of cells found more food or a bit more warmth, it could grow bigger. This did not happen quickly, but every change, even the small ones, gave life another chance to develop. The world above the ocean stayed ice-covered for a very long time. The storms kept blowing, the cold stayed strong, and the silence never left. Underneath, in the safe darkness, Life did its best to move forward step by step. There were no clear seasons like we know today. There were no days that were noticeably warmer. This made everything about life very slow. Living things that could wait for a long time without food, that could share warmth, or that could use almost any chemical as energy became the most common. The pressure of all the ice above shaped the rock and floor of the ocean. Sometimes new deep valleys were formed under the weight. These moving rocks and changing oceans helped mix the water a little, spreading the sparse warmth and chemicals and letting life reach new places. Every small success for life was important. Even though Earth seemed empty and frozen, millions of tiny steps were happening beneath the surface. Little by little, these steps added up and gave the future a path. The groups of cells grew together, became better at living in the darkness, and made the very first big changes in the history of life. As the harsh age of Snowball Earth continued, the ocean under the ice became the only place where life could survive and grow. The group of living things that managed to make it through the cold, darkness, and hunger would one day become the starting point for all animals and plants. All the slow progress, all the small new ways of living would form the path for more complex life in the future. The frozen quiet on the surface of the earth lasted for millions of years more, but all the time, deep under the silent ice, life continued quietly, preparing for a world that would one day change again. Beneath the silent frozen world above, where snow and ice covered the whole planet for many millions of years, only a few living things could survive. These small forms of life kept going in the cold, dark ocean deep under the thick layers of ice. The world above was empty, with no plants and no animals. There was only white ice and gray clouds, and nothing moved. But far below, hidden from the cold winds and harsh storms, life found a way to keep living. In the deepest water, the warmth from inside the earth helped make some places different. Here, in cracks on the ocean floor, heat and chemicals bubbled up from under the rocks. These warm spots did not look special, but for the simple microbes living there, they meant life or death. Many microbes used the energy from the chemicals brought up from below. They did not need sunlight because there was none. Every meal and every new step forward depended on using what the earth gave them from inside. These special places, where heat and chemicals rose up, are known as hydrothermal vents. Around these vents, the water felt warmer than in the rest of the cold sea. Simple microbes gathered here in large numbers, making mats and groups. Each lived by taking in chemicals and using them as food. They shared space on the rocks, some floating in the warm water, others sticking to the hard ground. In this dark world, every bit of energy and food was very important. The groups that learned to share or to use new kinds of chemical energy lasted longer. Some microbes formed thick layers on the rocks near the vents. These mats grew slowly, but over time they spread out, making safe places for more life to grow nearby. Every living thing in these areas had to make the most of each small change. Some cells joined together more tightly, protecting each other from the cold water outside the vent. Others found ways to use new chemicals as food, while some could hold on to the rocks better and not get pushed away by the moving water. Every change, even a very small one, made the group a little stronger. Sometimes cold water mixed with the hot water from the vent. The quick change in temperature could be dangerous, and not all microbes survived these moments. The ones that did could grow and form new mats or colonies. These strong groups would take over more space until a new change in the water or rocks forced things to start again. Over time, life at the hydrothermal vents became the best chance for any living thing to survive on Earth. Far away from the vents, the ocean stayed cold and dark. It was much harder for life to survive. There was very little food and no warm places to rest. Only a few simple microbes managed to live in these hard places. Some floated in the cold, deep water, waiting for a chance piece of chemical food to reach them. Others clung to rocks far from the warm spots, staying still for long times, almost sleeping until something changed. The ocean around them moved slowly, cold currents carrying any small bits of food from place to place. Sometimes, rocks shifted deep below and new cracks opened in the ocean floor. When a new hydrothermal vent was born, it started to send hot water and chemicals into the sea. This brought new hope to any living things close by. Microbes would move to the new vent, quickly taking advantage of the warmth and food. The group at the vent would soon grow, and new mats would form on the fresh rock. These vents changed over time. Some would close, trapping the life there, while others would become bigger, letting more living things share the space. The story of life was written by these slow changes, where only the strongest or most adaptable could survive. The thick ice above kept most sunlight away from the ocean. Very little light made it down through the ice. The ice was often nearly a mile thick in places, blocking out almost all hope of light and warmth from the sun. For the microbes below, this world felt endless and always the same, cold, dark, and silent. There was no chance for trees or anything with leaves to grow because there was no sun for them to use. Animals did not yet exist, so only these tiny life forms lived in the darkness. Even though the world was so cold and still, small changes in life were always happening. Some cells joined together to make thicker mats. Some learned to use new types of energy from the vent chemicals. Others could break down different minerals and use them for food. These small changes took millions of years, but they slowly made the living things a little stronger or a little more suited to life near the vents. Not all changes were good. Sometimes a big change, like too much heat or not enough food, would kill off many of the microbes in a group. When this happened, the survivors were often the ones who were a bit different from the others. They were able to do something special, like use a rare chemical or grow faster when food was scarce. Over very long periods, these survivors passed on their ways of living to new cells, helping life get better in facing hard times. There were many types of chemicals coming out of the rocks at the bottom of the ocean. Some were easy for microbes to use, like simple gases. Others were more difficult, but over time, different microbes learned to use these too. Each group of microbes had its own way of using the chemicals. In this way, many kinds of microbes could live together in the same place without fighting for exactly the same food. The water near the vents was sometimes so hot that nothing could live right at the center. But just a few feet away, the warmth was enough for life to gather. These special places were crowded, while, further out, the cold water was empty. In this balance between warmth and cold, food and hunger, life quietly grew. The story of every single cell was written by these silent battles for survival. Sometimes the mats near the hydrothermal vents became so large that pieces would break off. When this happened, small colonies of microbes got carried away in the water. If they landed somewhere safe, such as near another warm vent or a crack with good chemicals, they could grow there. If not, the frozen water would quickly end the colony's life. Over long times, this way let microbes move to new places, even though most ocean was still empty and very cold. Sharing and working together became very important. When food was very limited, some microbes started to do different jobs within their group. One kind might collect a certain type of chemical, while another would use it to make food for the whole group. Even though these jobs were simple, they meant the group could grow a little bigger or survive a little longer. Little by little, these ways of working together made life more complex. Life in the cold darkness did not mean life stopped changing. Each cell that survived was a small improvement over the one before. Over millions of years, some microbes grew special walls to keep out harmful chemicals or cold water. Some made simple covers around their whole group. This gave better protection, letting the mats last through times when the vents slowed down or food ran low. These simple walls were not the same as the shells or bones animals would have far in the future, but they were a first step. Beyond hydrothermal vents, some other special places helped life hang on. Rarely, volcanic eruptions under the ice brought even more heat and chemicals to the water. When this happened, living things would quickly gather to make the most of the new chance. Sometimes, these new places did not last long. They might close up, cool down, or run out of chemicals, but for a while, they let new groups of microbes survive and grow. The thick ice above did not always stay the same. From year to year, or even from century to century, the weight of the ice could get heavier or lighter. This might make small cracks or holes through the ice. In rare moments, these cracks let in a little more air from above or let small bits of dust reach the sea. Very rarely, this let other chemicals mix into the water, sometimes helping microbes find new ways to live. In all this time, no larger creatures could live. There were no fish with fins, no worms, and no clams at the bottom. There were not even the simplest soft-bodied animals. Every form of life was built from cells, sometimes living alone, sometimes working together, sometimes forming mats or groups. They were the beginning of all the larger, more complex life to come. The darkness was never complete. Sometimes chemical reactions in the water or small changes deep below the rocks made tiny sparks of light, a kind that no animal could see, but that was there for any future life to use. These soft glows did not change the ice above or give warmth, but they were part of the strange world at the bottom of the sea. Food was still the biggest problem. Even at the hydrothermal vents, there was never as much energy as sunlight could give. Even though the vents let life survive, they did not give as much power as a sunny day could. This kept most living things very small and very slow. Growth was measured not in days but in many thousands or millions of years. Only the best and most clever living things could do well in such a world. Microbes also changed the water around them. As huge numbers of them lived and died, they added their own chemicals to the sea. Some made small bits of gas which would mix with water and sometimes escape into the tiny cracks above. Over millions of years, even these small changes could slowly build up, making new chances for life or making things a bit easier for future living things. Sometimes, a big change would happen. A crack in the ocean floor might close, stopping the flow of hot water at a vent. The living mats there would start to die out, and only the cells quick enough to leave or those close to a new warm spot would survive. The story of life in these times was full of starts and stops, and every new beginning meant another chance for cells to become better at living together. Most of the world's ocean floor was never touched by these vents. The groups of life close to the warm places were lucky. Those who found no food or warmth simply ended. But because the ocean was so big, there were always a few places left, hidden, dark, and gently warmed by the earth, where small groups could keep finding new ways to stay alive. In these places, small steps kept happening. Simple cells became a little more organized. Groups worked together a little better. Walls grew a little stronger. Tiny gains, made over thousands or millions of years, slowly gave life more tools to survive. The story of these times is not about speed or size. It is about the quiet work of life, making the best of little food, little warmth, and very hard conditions. Everything living in this age was simple, but filled with the hope of new change. The world above was white and silent, but the world below never truly stopped. Slowly, the strength gained by living under harsh ice helped shape the living things into new forms. Without warm sunlight or easy food, only the cells that could share, adapt, and protect their small groups survived. Each new form was the start of a better way, still simple but full of promise. This quiet fight to survive under the ice would make it possible for life to take bigger steps in the future. The struggle in the dark, the joining in groups, and the clever ways to use chemicals and heat meant that, if the world ever became warmer, life would be ready to grow in amazing new ways. All of the Earth's living things in this long frozen age depended on these hidden groups under the ice. The world was getting ready, even if no one could see it. The story of life under the ice was still being written, as simple cells held on in the darkness, waiting for a chance to fill the world with new life. Life in the deep, cold ocean moved on with only the smallest and slowest of steps. All the world above the ice was empty, with no light, no sound, and no movement. Down below, hidden away, the earliest living things continued their quiet work. For millions and millions of years, the story of Earth was written by these simple cells, sometimes alone, sometimes grouped together, always searching for a way to keep living in harsh conditions without sunlight or warmth. Inside their tiny worlds, these simple living things changed very slowly. Every time they made a copy of themselves, there was a small chance that the new cell was a little bit different. Some of these changes did not help and soon disappeared, but others, by chance, made it easier for the new cell to use food, stick to a rock, or stay safe near the heat and chemicals in the ocean. These helpful changes were passed on to new cells little by little, one generation at a time. With so many years and so many cells, a whole new way of living began to form. Sometimes single cells started working together and sticking to each other in little groups. For a long time, these were just small mats or layers, but over the ages, something bigger happened. Some cells began to divide the jobs among themselves. One type of cell would gather food, another would hold the group in place, and another would remove waste. This made the whole group stronger and let it last longer without food or warmth. This slow change is called evolution. Evolution is the way living things slowly become better at surviving. It is not fast. Each step is so small, nothing seems different from one generation to the next. But over millions of years, the smallest changes add up and make life more complex. In the frozen darkness, this careful way forward was the only choice. The first groups of cells started sharing food. Sometimes the group would catch a piece of chemical food, and all the cells in the group would use it together. If part of the group was cut off or killed, the cells that survived would keep going, using the food or warmth left behind. Over many, many generations, groups with better ways to share would last longer and become more common. Other small changes happened too. Sometimes the walls between cells became a little stronger. This helped protect the group from changes in the water, like when a current brought in cold or dangerous chemicals. Some groups formed flat shapes, spreading over the rocks. Others became ball-shaped, which helped them roll slowly if the water moved. Some learned to open small holes in their walls to let chemicals in and out, making food and waste flow easily between the cells. All these changes were slow and simple, but each one made life a bit more prepared for the hard world under the ice. Life could not grow big, but it could grow together. Simple groups of cells began to be the rule, not the exception. The groups did not fight with each other very much because there was little energy to waste. Instead, most focused on staying alive, using every piece of food, every bit of warmth, and every small advantage given by change. Sometimes, when a group of cells separated, each new piece would start growing as a new group. These new groups were often just like the old one, but every now and then a small difference would be passed along. If that change helped the group to live longer or use food better, it stayed. If not, it slowly faded away. and only the best groups survived. The process of slow, careful change went on under the ice for millions of years. The world was too harsh for anything big or fast to survive, so only tiny steps were possible. Little by little, life was getting ready for something greater, even if no living thing knew it at the time. Groups of cells began to look more and more unlike the single cells that had come before. Some became thick mats holding tight to the rocks and sharing chemicals. Others made soft tubes, forming lines and circles. Some even made shapes that let them hold more warmth or store food for the coldest times. The very smallest difference over a long enough time meant the group could survive just a bit longer. As millions of years passed, these groups grew more complex. Some added more types of cells for different jobs. Now there might be one kind that looked for food, another that built thick walls, and another that made the group stick in one place. Some groups could break down old or broken cells and use the pieces to help new cells grow. These simple steps made the group stronger and let it last even through the hardest cold or longest dark. Inside the group, single cells slowly lost their own independence. They depended on the group to get food and to stay safe. The group, in turn, depended on every cell doing its job. If one kind of cell stopped working, the group might die. But as long as each cell did what it should, the group had a much better chance of surviving than any cell on its own. Sometimes, a new kind of cell would appear. If it did something different, and if that was useful, it might spread through the group. Over time, many types of cells found in one group could mean the group had many jobs, many protections, and many ways to stay alive. In the darkness below the ice, the process of change kept going at a very slow pace. Sometimes, a group of cells found a new way to feed or stay warm. That group would do well, and eventually the method would spread to other groups by small steps. Groups that did not keep up would not last, and new ways of living would take over. Changes in the chemicals at the hydrothermal vents sometimes helped speed up evolution. If a new chemical started coming up, only groups able to use it could stay alive there. Sometimes the heat changed or the flow of the vent slowed down, making it hard to survive. The groups most able to handle these changes kept living, while the others disappeared. The harsh environment made every bit of progress slow. No one mutation or change was so big that it changed life overnight. Instead, progress was counted in the smallest steps over long, cold centuries. But inside the quiet, dark ocean, the story of life became more interesting every year. Over time, the groups of cells started to become so different from their single-celled ancestors that they began to be something new. Though still very simple, these early multi-celled life forms could do things single cells never could. They could eat more types of food, hold onto the rocks during strong currents, and fix damage to their bodies. Some could close up if the water grew too cold, and others could move a small distance to find warmth or food. Some groups began sending out small pieces of themselves, not just as copies, but as special starter cells that could grow quickly in new places. These were the earliest hints of what would one day be called reproduction. The most successful groups found new and better ways to keep their kind alive, even if the conditions changed again. Still, all changes happened inside strict limits. Energy was always low. There was never enough oxygen or warmth to allow fast or sudden growth. Everything that survived did so by using as little energy as possible and by working together with others around it. Even as days, years, and centuries passed without much visible difference, important events happened in the slow work of evolution. At moments when chemicals changed or when warmth became less, the strongest groups survived and the weaker were lost. Each loss opened space for another new idea of cell organization or for another job inside the group. It was as if life kept trying over and over, each time a little better than before. Many of the first changes that worked for group living are now seen in the most basic features of animals today. Dividing jobs between different types of cells let the early groups grow a bit bigger and live a bit longer. Special skin cells on the outside, eating cells in the middle, and cleaning cells at the back became common features. Groups made of these parts had the best chance to survive in the harsh, dark world. Though most of the time change was slow, sometimes a group would suddenly take a new step. If a hydrothermal vent grew much hotter, groups close by had to change or be lost. Some learned to grow tougher skins. Some discovered new chemicals in the hot water that could be used for food. In times of special cold, only the tightest, best organized groups lasted through. Little by little, life became less like separate cells and more like a single, larger body. New kinds of group shapes started to appear. Instead of all cells being the same, some groups became made of long lines of cells. Some became flat like a wide, thin leaf, and others looked more like small bowls or hollow tubes. Each new shape allowed the group to use the small bits of food and heat in new ways. These earliest multi-celled creatures tried everything the slow process of evolution could invent. Many groups still failed when food ran out or when chemicals changed. But for every loss, there was a chance for another new group to succeed in a different way. Life under the ice was always hard, always slow, but always pressing forward in tiny steps. The simplest types of reproduction became more common. Some groups would break in two when they grew big enough, and each piece would continue growing in its own way. Others sent out very small starter cells, which settled wherever the right food and chemicals were found. Over time, these methods allowed some groups of multi-celled life to spread far from the place where they began. The oldest fossils from this frozen age do not show animals with heads or tails or any body parts at all. They show only simple shapes, small discs, blobs, or thin mats of cells. But inside those simple bodies were the beginnings of everything animals would one day become. Protection, feeding, cleaning, and holding together, these were the first skills learned by evolution in the darkness far below the ice. Nothing was quick. The group with even the smallest advantage could last a little longer, feed a little better, or move just a bit to a safer place. Whatever worked became a tiny foundation for the next step, and for millions of years these foundations built up the slow, careful history of life. The lessons of sharing, dividing jobs, and making strong group walls would be important far past the time of snow and ice. These steps set the foundation for animals with tissues and organs, for creatures with shapes and senses that could one day live above the ice and in the light. While the surface of the world was still silent and frozen, the ocean below quietly filled with these new multi-celled groups. Each was just a little more complex than the last, and each carried new ways of living learned from millions of years of darkness and cold. The frozen age did not end quickly. For a very long time, the only story was slow change and slow growth under the ice. But with every step, life became more ready for anything the world could give. Each small group that shared, protected, and learned to survive was building a future that no living thing could imagine, even in the darkness deep below the ice. Deep beneath the thick frozen ice, new ways of living were appearing. Inside the dark oceans, the simple groups of cells kept trying new forms. The cold world above stayed silent and empty, but in the water below, these simple groups continued their slow work. Over countless years, small changes made some groups a little different, a little more able to cope with the cold, the darkness, and the low food supply. From these careful steps, something new started to appear. A very long time before, all living things were made from just one cell each. These first life forms were too small to see without help. They could float in the water or stick to rocks. When the world grew cold and ice covered the sea, single cells had a hard time surviving. It was safer and easier to live in a group. Working together made every cell stronger. At first, groups were just clumps of cells that joined side by side. In the beginning, all the cells in the group were almost the same. They shared tasks, helping find food and stay safe. But as more years passed, some groups started to change from the inside. Some cells did one job, like holding the group tight against a rock. Some worked to capture food or to clean waste from between the cells. When each cell did its own part, the group could survive longer. This was one of the most important moments in the story of life. As these groups of cells learned to cooperate, new shapes appeared. Some groups were flat, spreading across rocks under the deep water. Others made long, thin tubes. Some became round, making simple balls of cells. Every shape had a purpose. A flat shape could stick easily to the sea floor. A tube shape helped food move through the middle of a group. A round shape could keep the inside cells safe from the cold water. The world was still frozen at this time. Great storms moved over the thick ice. No plant, animal, or insect lived on land. But in the quiet dark under the ocean ice, simple life kept growing step by step. With little sunlight, life could not use energy from the sun. Instead, these groups depended on chemicals from cracks in the sea floor or what little food drifted through from other places. Each small group copied itself by splitting. When a group grew large, it broke into smaller pieces. Each piece floated or stuck to a spot and began again. Sometimes the new group was exactly like the old one. Sometimes a simple change happened. If that change helped the group find more food or live longer, then the group with the change survived better. Bit by bit, groups with the best changes became more common. Over long stretches of time, more and more groups gained new skills. Some could sense chemicals around them and moved very slowly towards better spots. Some had outside cells that became a bit harder, helping protect inside cells from the cold. Others developed thin layers that let only certain food or chemicals pass through. These were not complex organs, but just the first hints of bodies with more than one part. The earliest multicelled life did not have eyes, mouths, arms, or legs. They did not have heads or tails. They looked like pads, tubes, or blobs sitting on the ocean floor. Each group's cells still did their jobs, but no group could yet swim or sense light. Their lives were slow and quiet, anchored in the dark, cold sea. Still, even in silence, small changes were important. Some groups had cells closer together, so food moved from one to another very easily. Other groups had more space between cells, letting water pass through. Some shapes caught more bits of food drifting in the water. Other shapes let them grow bigger before needing to split apart. Every living group needed food and energy, and both were always hard to find. Sometimes, a new group grew near a vent with warm chemicals, and life got easier for a short time. But vents could change, sending heat somewhere else, or closing up forever. When that happened, only the strongest, most able groups survived. In the cold ocean, more kinds of multicelled life began to appear. Some stuck flat to rocks, building layers on top of each other. Others carefully reached out and attached to new stones or small pieces of hard ground. These slow movements spread life to new places, though never far from warmth and food. The groups lived very quietly. They never hunted or chased. Instead, they waited for food to drift past or for warm chemical water to wash over them. The cells inside them did not yet talk to each other, but they reacted together when something important happened nearby. If the water grew much colder, the whole group might pull closer together or stay still to wait it out. Some groups lived in places with a little more oxygen. Over time, groups that could use small amounts of oxygen had a new advantage. Having more oxygen helped groups grow a bit bigger. Bigger groups could store more food inside and could survive when outside food and warmth were low. Every time a group split and made new copies, there was a chance for change. Many changes did nothing, but some made life just a little easier. Some groups made small holes between cells to let important chemicals inside. Some closed off parts of the group to save energy. Even simple tricks like these made a difference over many years. As the years passed, life became more organized. Some groups had a type of skin cell on the outside, acting as protection. Others had food cells in the middle to gather and share food. As these patterns were passed along, more groups started to look and act the same on the inside. Inside these quiet mats and tubes, all the action was small and steady. Cells took in food, used energy, removed waste, and copied themselves again and again. The groups that lasted best were the ones whose cells worked together well. Step by step, the slow joining of cells became more common. Groups with better ways to handle food and share energy grew bigger, sometimes reaching sizes you could see with your eye if you were there. These first bodies were soft and shapeless, but they were stronger and safer than single cells. From time to time, a new chemical or a bit more warmth from the vents made things better for a while. When this happened, groups could spread out more on the ocean floor or send out more pieces to start their own life elsewhere. This spreading helped give life more new chances to change again. Some groups started joining together to make layers, one on top of another. These soft mats could cover a bigger area and make it easier for more cells to live together. Slowly, these mats grew thicker and more stable, lasting longer through the cold. The first shapes that could keep growing and not fall apart right away became more common in the dark sea. Some grew high, making small towers near the warm cracks. Some spread out to cover as much ground as possible. Each new shape was tested by cold, darkness, and lack of food. Sometimes when a mat or tube broke apart, only a few pieces kept living. These strong survivors carried the lessons of working together, new cell types, and new shapes. In time, these survivors built new mats, tubes, and blobs, and these became the start of even more complex life. When chemicals in the ocean changed, groups with more types of cell jobs survived best. Some chemicals were easy to use, but others were hard. Multi-celled mats with many cell types could use more kinds of energy and food. Even the tiniest ability to use a new chemical meant better chances to live through harsh changes. After millions and millions of years in the darkness, multi-celled life forms started to become the most common type of living thing near warm sea cracks. The ocean was still cold and still held little oxygen, but these new groups made the best use of every small resource. All of these groups were soft. They had no bones, shells, or teeth, but by joining, they could grow much bigger than before. Some clung tight to rocks, others floated when the water was calm. Most never moved at all, but a few groups could change shape slightly to help catch drifting food. Over long stretches of time, as these mats and blobs became more complex, the whole world under the ice began to change very slowly. With every step, these simple living things grew just a little more able to survive. Strong groups lasted for many generations, passing new ways of living from cell to cell, group to group. In this way, the ocean under the ice became filled with many forms of simple life, all working quietly to make the most of what little they had. There were no fast changes, just tiny improvements building up year after year. Life was still slow, but now everything was ready for something greater. The world was filled with soft shapes, mats and tubes, each one showing millions of years of trying, surviving and changing, all deep in the darkness where the sun could not reach. The ocean was full of simple bodies, sharing food, moving waste, and sometimes making new shapes when they split apart. These early steps were the quiet beginning of animals. Each group, soft and silent, was a new answer to the hard world above. Long after the first groups appeared, some cells inside began to react with each other more. Little by little, they shared simple signals, helping the whole group respond together. A push of water, a touch from a rock, or a tiny bit more warmth could make the whole group act as one, even in very simple ways. The joining and the slow building of bodies with different cell types taught life the first lessons of cooperation. Survival was best when each part of the group did just the right job at just the right time. All these steps happened while the world stayed frozen. No animals walked or swam in the cold, lightless water above. No plants grew along the land. But deep within the sea, these quiet bodies with many cells showed what the first true multicellular life could be. Because these early bodies were simple and had no hard parts, they rarely left marks behind in rocks. Still, today, small hints remain, faint patterns that tell us about flat mats or small soft discs. These are the first signposts from a time when life was learning how to be more than just a single cell. Even as everything on the surface remained silent and icy, the ocean was learning the rules that would make all future life possible: join together, share food, protect each other, and grow in simple bodies with different cell jobs. In the long darkness of these ancient times, every bit of progress was slow, but slowly the first multicellular life changed the ocean floor. Little by little, blobs, tubes, and flat mats filled every spot where warm cracks gave out food. With soft bodies, shared tasks, and the ability to hold on through cold and darkness, these groups became the foundation of all animals to come. Every animal, simple or complex, would build on these earliest ways of living together. The ocean was now a place filled with the quiet beginnings of future animals. Each group of cells, each soft mat, was a small step in a journey that would someday bring new shapes, new movements, and new ways of living to the whole world. The ocean below the ice was home to many soft groups of cells, each living quietly and slowly. All of them worked together in simple ways, sharing food and keeping each other safe. Their bodies did not have hard parts or special organs. They did not have eyes or mouths, or even any way to move quickly. Still, these gentle forms filled the dark sea, holding onto rocks or floating gently when the water allowed. Their lives showed the first steps toward animals. Among these living things, most had shapes that were easy to make. A group might be flat, like a thin mat spread across the ocean floor. Other groups formed soft pads or round discs, joining many cells in a gentle layer. A few grew into long, tube-like bodies, stretching slowly over the rocks. Some looked a little like leaves with wide, simple shapes that caught more of the food floating by. Every shape was soft and could bend if the water pushed it, but none could swim or travel far from where it started. The early animals did not have jaws, teeth, or bones. None of them could bite, chew, or grab. Instead, they lived by letting small bits of food drift toward them in the water. When a bit of food touched the body, special cells would take it in and share it with the rest of the group. Some animals absorbed tiny bits of food straight from the water, passing it from cell to cell. Others waited for small particles to settle on their soft bodies. Life was slow and quiet, but it was enough. No animal could see or hear, as there were no eyes or ears. Each simple creature felt its world only through touch, when water or a bit of food brushed against it. Sometimes a group of cells would tighten or pull in a little when something touched it. This simple way of feeling was a new step for life, helping keep the animals safe or making it easier to find food in the dark water. Most of these soft animals did not move much. Some stayed in the same place for their whole lives, only moving if the water was very strong. Others could change their shape a very small amount to reach food or to hold on more firmly. A few could slide slowly across the mud or rock, using simple ways to push or pull their body. These movements were never quick. They always used very little energy because energy and food were hard to find. Inside the soft bodies, different cells had different jobs. Some cells formed the skin, holding the group together and protecting it from cold water. Other cells inside took care of food, moving it from one part to another. A few cells got rid of waste, helping keep the group clean and healthy. In every animal, even the simplest ones, life was built on teamwork. As time went on, groups that could share and protect each other lived longer. Some shaped themselves to allow more food to pass through or to keep waste away. In places where the water was a little warmer or where more chemical food was found, groups could grow larger. These patches of bigger animals covered the rocks, sometimes forming gentle gardens of soft discs or mats. But there was never one animal much bigger than the rest. The world stayed a place of small, simple shapes, all soft and quiet. The dark sea, hidden far from sunlight, held new beginnings in every group. The first animals, though simple, were a big step forward from single cells or even soft mats. Now, living things could grow larger, could survive together for longer, and could learn new ways to work as a team. Each new form was shaped by the hard world around it. Every winter was cold, with little oxygen and very little light. Survival was never easy. Animals that needed less food could last longer. Shapes that let water flow gently over their bodies made it easier to feed. Animals that shared well with their neighbors were strongest of all, living through the harshest years and making new groups when the world allowed. Once in a long while, a few soft-bodied animals would move to a new place on the sea floor. They might float away when a water current passed through, or break into pieces that settled far from where they grew. If the new place had food and some warmth, new groups could start there. In this slow way, animal life covered more and more of the ocean bottom. Still, none of these early animals hunted others or chased them down. All lived quietly, taking what food they could find from the water. There were no predators, no teeth, and no fast movements. Life stayed simple for millions of years. When an animal died, its soft body would sink into the mud or fall apart in the water. Most left no trace, but sometimes the shape of a body made a mark in the muddy sea floor. Over long ages, these marks became the first fossils. Now, millions of years later, the stones hold faint shapes that let people know what these early animals looked like. Soft discs, long tubes, and leaf-like forms show that life was gentle and slow. Sometimes big changes happened. A warm current might bring more food, letting animals grow larger for a short while. If the water around a group became too cold or too low in oxygen, many animals in that spot could die. In these hard times, only the smallest or strongest would last, starting new groups when the world became a bit better again. Every small difference in shape or way of living could matter. Animals with slightly thicker skin could handle the cold a bit better. Those that joined in wider mats could share more food. Animals with simple ways to hold on to rocks were not washed away when water moved fast. Over years and years, useful changes became more common, passed from one group to the next. All of the progress was slow. No animal developed arms or eyes. None could swim fast or jump. Life stayed strongly connected to the quiet ocean floor, near the best spots for food and warmth. Tiny steps made each group of cells just a little more prepared for the next hard period. By growing and surviving in this way, these animals were getting ready for changes that were still far in the future. Living together was important for more than food. animals formed mats or whole fields of soft bodies, making a safe place for even more living things. Sometimes tiny single cells or smaller groups of cells would grow between the soft animals. These extra shapes added to the quiet life on the sea floor, using up every bit of food that was available. Nothing happened quickly. The journey from single cell to group and from group to early animal was measured in millions of years. Each new step depended on the one before. Every animal with a new helpful body part or a better way to find food made it easier for its kind to survive another cold year. Most of the world was still empty above the ice. On land, there were only rocks and thick white snow. In the gray sky, storms passed and winds blew, but nothing lived. But deep below, all the slow progress in the sea was setting the stage for what would come next. Some animals developed simple ways to sense their surroundings. They could feel changes in the water or detect when a new piece of food landed on their body. Sometimes the signal from one cell passed to another, making the whole group react. This was the start of very simple communication between cells, a first quiet step toward sensing the world. Many groups split and made new groups. The new animals would spread across the ocean floor, waiting for food, sharing warmth, and learning small new ways to live better. Larger groups could sometimes split into even more small bodies, each trying to find a good place. This slow sharing out made sure no part of the ocean was left unused when food was there. Once in a long while, a slightly different animal appeared, a new shape, a new way to move, or a new trick for staying alive. If it helped, the skill or shape was used again in the next group. If not, it faded, and life stayed the same as it had been. Only very helpful differences lasted through the generations. The first animals changed the ocean floor. Their soft bodies smoothed out the mud, made small, safe places for other animals, and tied the rocks and sand together. In this dark, cold world, every new animal was another tiny step forward in the story of life. In some places, so many soft animals covered the ground that they made entire fields of discs, mats, or gentle fans. These places were special because living close together made life just a little safer. If one animal found food, others nearby had a better chance of surviving. If waste from one animal moved away, nearby animals could stay clean and healthy for longer. Nothing about these early animals was quick or sudden. Every part of their lives was slow and careful. When a current brought a bit of warmth or a new kind of chemical, animals that could use it had the best chance to last. Animals that were too weak or that could not handle a small change slowly disappeared. Inside these animals, the simple beginnings of living together were always at work. Food and energy passed from cell to cell. Waste left through simple openings. If something touched the animal, all the cells could react, closing the soft body or pulling it tight to the rock. Over even more millions of years, some groups found better ways to stick together. A tighter mat could handle hard water or a sudden cold current. A thicker body could store just a bit more food. Each time the world changed, only the best groups survived to pass on their way of living. The dark ocean below the ancient ice was full of these first animals. They never made noise or moved quickly, but their lives were full of quiet work. Every day, energy and food moved through simple bodies. Every season, some animals died, and new ones started in their place. In long ages, their shapes left faint marks in the rocks, showing gentle bodies living slow, important lives. There were still no animals with eyes, bones, or shells. Even so, the ocean floor was rich with soft, early life. All these forms of life shared the water with many single cells, with blobs and mats. The whole sea was learning, becoming more prepared for the day something new would happen to change the world again. Oxygen in the water began to grow very slowly in some places. When this happened, animals could sometimes grow a little bigger or live a little longer. When the oxygen dropped again, only the smallest and simplest survived. Even these short times of better conditions helped animals learn and change, giving the sea more types of life than ever before. No single animal or shape was the best. Every kind of improvement, thicker skin, wider mats, new ways to share food, or better ways to stick to rocks, had its place in the slow sea of life. By surviving, growing, and dying, each animal left behind the beginning of something new for future bodies to use. Beneath the thick frozen cover, the sea held a treasure of gentle shapes and silent teamwork. These first animals did not know what would come in the years ahead. They did not know if the world would become warmer or stay cold forever. But living in this way, every group and every simple animal was preparing for change, for the chance to become more than what it already was. The quiet life of the first animals filled the ocean with endless, patient hope for what could happen next. The sea under the thick ice was full of gentle shapes waiting for change. Each animal, each soft mat, lived with simple hope. For a very long time, nothing on the outside seemed to shift. The world above was still covered in deep, hard snow that did not melt. No trees grew, and no grass showed any green. The sky was heavy with gray clouds, and the land stayed empty and white as far as anyone could ever see. Everything was quiet, cold, and still. Far below, the soft animals kept living in the darkness. Their slow lives were measured by the food and warmth they could find. Even so, under all the hard ice, something important was beginning to happen. It started very slowly, so slowly that no living creature noticed. Deep in the ground, slow changes built up and touched the sky above. Gases began to rise from the inside of the earth. These came out through cracks and holes, often from volcanoes. At first, the change was too small to matter, but as time passed, more and more gas was added to the air. These special gases did not leave the earth. Instead, they began to act like a blanket very high up in the sky. They trapped more of the sun's warmth as it reached the planet. Before this, the bright white ice had pushed most of the heat away, back into space. Now, a tiny bit of warmth was kept close to the ground, and the air above started to get just a little warmer. This slow warming did not happen in a single year or even in a handful of years. It took many thousands of years. First, the ice on the very top of mountains began to shrink. As more warmth stayed in the air, the thick ice at the edges of the oceans became a little thinner. Most of the world was still covered in solid snow and frost, but the slow, steady change did not stop. More volcanoes and deep holes in the ground sent out more gas every year. Each new bit of gas added to the blanket above, giving a very gentle help to the sun's heat. Day by day, the planet warmed little by little. Sometimes the cold would return for a while, as the sun's light was still weak. But slowly, the world was learning to keep its own warmth again. As the ice grew weaker, new changes began in the sea. Where the ice was thin, sunlight could pass through a little more each day. The ocean under these parts started to change from total darkness to gray, and then to a soft blue. This meant more energy for life. The first living things to use this new light were tiny cells, much like the oldest microbes. They could take the sun's energy and turn it into food. Some small mats on the seafloor became a little greener, using the new light that fell through open cracks in the ice. The animals with soft bodies, which had spent all their lives in darkness, found a new world opening above them. Some moved toward places with just a little light, while others stayed deep in the calm and shadowed water. With sunlight came new energy, and slowly more food for all life. The ice itself did not disappear all at once. Great sheets of white stayed on land and over the sea for a long time, but each warm day melted a little bit from the top. Rivers of cold water ran over the ice and down toward the sea. Small streams cut through the white, carrying broken stone and dirt. These streams, even if tiny, helped remove more ice every day. The melting ice flowed into the sea, making the top layer of water less salty and much fresher than before. For the first time in millions of years, the ocean began to mix with new water. This fresh water spread out in wide, thin layers, bringing new chemicals and helping mix oxygen into the deep sea. With every drop of melted ice, the changes grew stronger. The air gained more gas from volcanoes, and the warmth from the sun reached the frost below. Over many thousands of years, the biggest sheets of ice started to break apart. Huge blocks floated out to sea and slowly melted. The sight must have been quiet but powerful, white ice falling into the water, breaking up into smaller pieces, and then slowly becoming part of the sea. As ice melted, sunlight was able to touch bigger and bigger pieces of ocean. The darkness faded and blue water began to shine. All the small living things that used sunlight now grew faster and in bigger numbers. This was the start of a great change. Life everywhere in the sea became stronger as there was more food and energy. Oxygen in the ocean also started to rise. Before, only a little oxygen could reach the deep water. Now, as sunlight grew and mats of tiny cells used new energy, more and more oxygen spread through the water. This helped all soft animals breathe and grow larger. In places where there was more sunlight, the animals could now survive for a longer time without being stopped by the dark or cold. With fresh water, extra chemicals, and new light, life found more places to grow. As time went on, the thick ice pulled away from more land and sea. Glaciers, which are big rivers of slow-moving ice, started to shrink. The sea's edge, once frozen and sharp, became open. Small waves moved over the sand and rocks for the first time in millions of years. When big pieces of ice broke loose, they sometimes carried dirt and stones far out into the sea, dropping them as they melted. These rocks became the proof, still hidden in the deep mud, that the whole world slowly changed from freeze to thaw. Where new sunlight reached the sea, many tiny plants and microbes turned blue and green, filling the top of the water with energy from the sun. More energy meant more food, and the quiet animals living below could grow a bit bigger. Some could now live in places that were bright during the day and dark at night, moving slowly toward the changing light. In rare places, where all the ice melted quickly or warm water from deep below reached the surface, animals were the first to feel the full power of the change. The oxygen here was richer, and food from sunlight was more common. Some soft-bodied animals grew larger and spread out into these new areas, becoming stronger and passing on these changes to new generations. As the ice continued to shrink, the land once hidden below was uncovered. The sun touched the bare earth, warming rocks that had not seen light for millions of years. No plants yet grew there, and no animals walked. The first living things to reach the new land were simple, tiny cells in the water that splashed or flooded onto the fresh dirt. These first steps made the ground ready for new life in the much later future. Day by day, warmer times spread across the planet. Long winters grew shorter, and more days brought soft, new sun. Storms of ice and snow still happened, but never as far or as strong as before. Each spring melted a little more ice, letting lakes and rivers start moving again. The sound of water running over rock was a sign that the world was waking up from its long sleep. With more sunlight over the sea, more kinds of living things began to appear. The food chains in the ocean changed. Small plants and microbes using the sun's energy grew fast and in many shapes. Soft animals that ate these tiny plants grew too. Now, animals did not only have to wait for food to fall from above. Many could catch tiny plants and floating bits in the moving water. Not every animal could use this new way of living. Those that could not eat the new plants, or that needed very cold, dark water, found fewer safe places to live. But the change made room for new types of animals. Some soft bodies became a little tougher, others became better at finding food or at living in brighter water. The increase of oxygen in the water also let animals grow into bigger groups. Now more animals could live together in the same place, sharing warmth and protecting each other. Some soft discs and mat shapes joined to cover much bigger areas of the ocean floor. As life in the ocean became richer, more and more shapes filled every part of the warm, open water. Old styles of life, which worked only in the darkest, coldest places, became less common. New animals, able to grow and move in light and with more oxygen, spread everywhere. With every passing generation, living things changed to use the world in better ways. Some found new food, others found new homes in the bright, growing sea. Soft bodies turned stronger and shapes changed as animals learned to live in the open water and on the fresher, lighter bottom. The quick rise of new life was not easy. Good times could become hard again if the weather grew cold or a storm covered the sea in ice once more. But in each place where the sun reached the water, life was stronger, faster, and much more able to survive. Animals now sometimes shared the sea bottom with plants and other cells that gathered light. The simple food web became more complex, with many paths for energy to move from one form of life to another. This richer world let even more types of life arise. The last big sheets of white finally melted after many ages. Glaciers pulled back, and the world looked greener and bluer. Once bare land began to see the first colors from small plants and tiny mats of life. Air above was now full of more oxygen, which spread everywhere, ready to be used by life in water and soon by life on land. The great melting of the ice changed the shape of rivers, lakes, and even the mountains. Water cut through rocks. Land shaped by the old, heavy snow took a new form, softer and more friendly for the future. The quiet world of never-ending winter was gone. After millions of years in the dark, life now began to fill every open space in the ocean. The animals that had learned to live fastest, to find food best, and to use new oxygen grew into even more new forms. The gentle, soft animals were no longer the only kind. New bodies and shapes would soon appear, showing how change brings endless hope and new beginnings. As the last pieces of thick, bright ice disappeared from the sea, the blue of the ocean shined under the sun. The world was open again. Where once only silence and stillness lived, a new chapter began, full of movement, growth, and the never-ending promise of life. With the ice almost gone and sunlight falling again on wide parts of the ocean, life in the sea became full of new changes. The air was warmer and richer with oxygen. The blue of the ocean glowed stronger where the sun touched water. On the ocean floor and in open water, more and more living things started to appear. Simple groups of cells, mats, and soft-bodied animals that had survived the long cold became the parents of newer, bolder types of life. Now, the world was ready for animals to try many new shapes, new ways to move, and new ways to live. In places where sunlight reached down into the water, plants and tiny living things that used the sun quickly grew in great numbers. These simple life forms turned sunlight and water into food. Because they could feed on the light, they could grow much faster than anything had before. With more plants, there was more food for animals that ate them. Every day, the ocean became richer, filled with new chances for all life. Animals that had once been soft, simple, and slow began to change, little by little. Some started to move faster. A few learned to sense their world in new ways. Most animals still had no eyes, legs, or jaws, but their soft bodies began to make simple changes. Some could bend from side to side, helping them drift or glide across mud and stones. A few could push parts of their body out and then pull them back in, letting them move very slowly toward food or away from hard places. In the rich sea, life kept trying new ideas. One very old group of animals began to change shape. They became long and thin, looking almost like a ribbon or a tube. With this new shape, moving in the water was easier. Other animals learned to make their bodies wider and flatter, which made it possible to rest close to the sea floor, where much food landed. Some groups became round, while others made tiny bumps or arms, helping them feel food in the water around them. Every small change in the way an animal looked or moved was decided by whether it helped the group survive. If a shape made finding food easier or avoiding danger possible, it was soon used by more and more animals. If the change did not work well, it faded away over many generations. In this way, life kept exploring, step by step, through the slow work of evolution. Simple animals began to look less like mats and blobs, and more like the early roots of the many life forms we now know. The air and water were now full of more oxygen than before. This meant that animals could make new types of bodies. Before, living things had to stay soft and small because there was not enough oxygen to let them grow large or fast. Now, animals could use more energy. Some grew into bigger groups, while others learned new ways to build simple support inside their bodies. Few had anything hard like bones or shells, but their bodies could now hold new shapes, stay together better, and fix themselves faster when hurt. Some early animals began to form what would one day be called muscles. These simple muscles could shorten and pull, letting the body move a little more than before. With these new parts, animals could now push through mud or sand, lift themselves very slowly, or squeeze their bodies to move along the sea bottom. Every new step made surviving easier and made it possible to find new food in different places. Other animals learned to sense where food, danger, or even other animals might be. A group of cells near the edge of the body could feel touch better. Some could sense simple changes in water or chemicals. If a bit of food or another animal touched them, they could react by moving away, curling up, or opening their body to catch food. These first, simple senses helped animals become aware of their world, even without eyes or ears or a mouth. As more oxygen filled the water, these senses grew a little more complex. A few groups of cells in the body worked to pass simple messages, sending signals from one part of the body to another very quickly. If one part sensed danger, the signal could reach the whole animal and help it move away or close up. These basic signals were the beginnings of what much later would become nerves and brains. The sea became a place of movement and gentle activity. Slow animals crawled or drifted on the sea bottom. Others grew taller, reaching above the mud to find more food. More shapes filled every small space in the water, each one taking a slightly different path to survive. Some animals started to live together in big groups, making lines or circles in the sand. By living close to one another, they could protect each other and share the best places to find food. Change was not easy or quick for any of these living things. Every new part of the body, every new way to move or feel, was tested by the hard world around them. If a storm passed, if a wave brought new kinds of water, or if the food changed, only the strongest bodies and best ideas lasted. The story of life was written in tiny steps, with millions and millions of quiet trials. In some places, animals learned to grow with special shapes. A few made wide, soft fans on their bodies to catch small food floating by. Others formed simple tubes that let water pass in and out, bringing food and carrying away waste. Animals with these new body plans spread across the sea bottom, covering it in new ways. Plants and tiny cells that made food from sunlight also filled the water, creating thick clouds of life where once there had been none. More animals learned to move up and down through the water, not just along the bottom. Some rose into higher water to find new kinds of food. Others found new homes far from the old resting places on rocks. The rise of these new body shapes and new movements meant the sea became a world of many layers, with life in every one. Soft animals changed most quickly in places with the most food and light. Where sunlight was strong and oxygen rich, animals grew a little bigger, moved a little faster, and learned to sense their world a little more clearly. In darker or colder parts, change was much slower, but every group kept searching for the best way to survive. Some animals started to feed on very small pieces of food floating around them. Others learned to eat small living things directly. The first steps toward animals hunting other animals had begun. Still, there were no fast hunters, no big teeth or hard shells. Life stayed soft, gentle, and mostly slow, but the door was open for the future. With more food and oxygen, the number of animals grew quickly. Large mats of soft bodies covered the seafloor in places, while others rose as gentle towers or thin fans. Now and then, a group of animals left behind a shape in the mud, and in later years, these became fossils. Studying them today, people can see how round discs and soft tubes were joined by new forms, longer, flatter, sometimes with the very first hints of simple arms, edges, or folds. Some places in the sea saw great changes when a new shape or movement spread. Animals with better ways to move or eat took over more of the best space. Those who could not keep up found smaller places to live or faded away. This was the gentle struggle of life, where each small improvement made survival a little easier and the path forward a little wider. As millions of years passed, the diversity of animals increased. Every shape and way of living that worked could be found somewhere. The oldest groups, like the soft mats and simple pads, were joined by animals with different parts for moving, feeding, or feeling. Some even grew tiny hairs or soft bristles to help them float or sense things in the water. The new world of life was possible only because of the slow rise of heat, light, and oxygen. Now, with the ocean open to the sun, even more new animals could appear. The gentle, soft-bodied animals became the base for everything. Later, animals would become stronger, harder, faster, and more complex, but every new line of life had its root in these slow, patient forms. Plants in the water continued to fill the sea with food. New kinds of plants and tiny living things appeared and grew. Many animals learned to change places as the food moved or as the water changed. Some migrated a small distance every day, while others stayed in protected places and waited for food to drift by. Every animal, plant, and tiny life form played a role in the sea's new food web. Energy from the sun fed the plants, which fed the animals, which helped change the water and even the land. More and more, the sea filled with movement and quiet building, step by step. There were still hard times. Sometimes the temperature went down, storms returned, or food grew scarce. Each new test made life stronger. Every time, animals and plants that could handle the challenge lived to make the next generations. Over and over, new shapes and ideas built on old ones. Some soft-bodied animals became the ancestors of creatures we know as jellyfish. These could push water around them, drifting in groups or alone through open water. Others became the ancestors of simple worms, sliding along the sea bottom or through soft mud, eating small pieces of food they found there. Even more new groups of animals appeared, each with a body plan that made a different life possible. Those with parts for feeling, moving, and eating could go to new places and find new food. As these living things tested all the world's empty spaces, the number and kinds of animals and plants kept growing. The open ocean and the sea floors now showed a new beauty, full of shapes, colors, and movements made possible by the light of the sun and the power of oxygen. In quiet places and busy ones, life found ways to use every chance and every opening. The sunrise and sunset brought daily changes to the sea's life, touching every animal, every plant, and every grain of sand. With no more great ice covering the earth and with more energy coming to the sea, animals and plants began to shape everything around them. The rocks and the mud were moved and changed by growing living things. Even the air above the water filled with new gases made by life below, helping make the planet kinder for later living things on sea and land. This new chapter in the story of the world began because life used everything it found: light, oxygen, food, water, and space. Each animal that crawled, each plant that floated, played a part in making the world ready for what would come after. As the generations passed, all the animals and plants sharing the sea built a rich, full world together. The gentle, soft ancestors of jellyfish and worms, the growing mats of green and blue plants, and all the new forms that joined in laid the way for life to keep changing and growing forever. As animals and plants kept filling the ocean, the world looked and felt more alive than ever before. The changes that had started so slowly in the dark under the ice now showed everywhere in the blue waters and in the new colors on the sea floor. New shapes and soft bodies moved and grew in every open space. The life that survived the coldest age began to make the world new. Before this time, for many millions of years, Earth had been silent and covered in thick ice. Only a few tiny living things managed to survive, holding on in the dark. Now, the work of millions of generations was everywhere. In each corner of the sea, small changes passed from life to life had built stronger, smarter, and more complex beings. Life was not only surviving, it was growing and changing the world itself. The hard times of snow and ice taught every living thing the lesson of survival. Only those who could share, work together, and change slowly were able to keep going. Every animal and plant in the New World carried some memory of the struggle under the ice. Groups that learned to pass food, to join together, to adapt to new conditions, became stronger. Each tiny improvement became part of the future life of Earth. As the ice melted more and more, the land appeared from under the white cover. Soft mats of tiny cells touched the bare rock. Blue and green colors, made by new kinds of life, covered places that had been empty for millions of years. These first steps on land were slow but important. In time, they would prepare even the hardest ground for the next living things. The ocean was now a place where animals and plants lived, fed, and changed each other's lives. Animals moved slowly at first, crawling over the mud and swimming in gentle ways. Plants grew in many shapes, floating or sticking to rocks. Food chains formed as small animals ate the plants, and larger animals learned to eat other animals. The life of the sea became a web where everything was connected. Each kind of life made the world a little different. Plants added oxygen to the air and water. Animals moving on the seafloor mixed the mud and carried food to new places. When plants and animals died, their bodies gave food to others. The cycles of life helped turn Earth into a better place for living. Every living thing was still simple compared to what would come later. Animals did not have bones, hard shells, or teeth. No birds or fish filled the water. No trees or flowers stood on land. But the world had entered a new age. Tiny changes inside simple bodies were building the first steps toward eyes, muscles, and more complex organs. Slowly, some animals learned to feel the world better. Their soft bodies formed parts to sense touch, then heat, and sometimes even light. Small parts of the body learned to bend or stretch. The earliest forms of energy moved through bodies as signals, allowing animals to sense food or danger. The first hints of movement, feeling, or simple nerves appeared, even if only in a basic way. plants filled the top of the water with color and shape. Some could float, others held onto rocks, and a few covered the sand. Oxygen from these plants spread into the air and water. With more oxygen, animals had new power to grow bigger or move further. On the sea floor, life made patterns that remained after animals died. Soft bodies pressed into mud made marks that turned into fossils as the mud became rock. Scientists today can see the faint shapes animals left behind. The quiet story of ancient life is written in those marks. New kinds of animals came from older shapes. Some looked like simple blobs, some like thin leaves, and some like simple discs or flat fans. Little by little, the bodies of animals became more than just a group of cells stuck together. Some started to have front and back, top and bottom. Others learned to fold or bend in special ways to help get food or avoid danger. Over millions of years, some of these early animals became the ancestors of all the creatures we know now. Slow changes put some on the path to become worms, others to become jellyfish, and others to make even more complex plans for the future. At the same time, the sea never stopped changing. New storms, cold periods, and times with less food tested every living thing. Each test brought new chances for life to change again. Every animal that could not handle a new problem was lost, and every animal that found a new answer helped the whole world move forward. Sometimes the changes inside animals were very small, such as the way cells stuck together. Other times, a new part or new way of living appeared. Each change that worked spread through the animal's group and became a step that could never be undone. The story of life moved in one direction only, toward more ways to live, more forms, and more chances to grow. Because the world was now full of living things, plants and animals kept shaping everything around them. Plants changed the water, and animals pushed mud or sand, opened space, or made new homes for others. Even the weather began to respond to the work of tiny living things that changed gases in the air. Every living thing on Earth today, from fish to people, first came from these simple, quiet beginnings. The ancient animals that grew in the sea after the long frozen time became the base for all future life. Their lives look simple when seen in fossils or stories, but without their slow steps, nothing in the modern world would exist. Many signs from the oldest times are still inside every living animal and plant. The way bodies are made from cells, how they use oxygen, and the way they sense touch or light come from these ancient days. The story of the world is inside every small part of our bodies, carried from the first groups of cells that survived under the ice. As life continued, animals grew stronger, smarter, and more able to move and sense the world. With time, shells, teeth, bones, eyes, and strong muscles would appear. Plants, too, would fill the land, turn air into food, and feed animals in new ways. Birds, fish, insects, and people all began as tiny steps taken at the end of the frozen age. Each new chapter in the history of life started from quiet changes made deep in the ocean. The struggle of living things to survive Snowball Earth gave the power to grow in every age that followed. What once looked impossible at the coldest and darkest time became the reason for the beauty and life found everywhere now. The world after the Great Freeze showed that hard times can bring the greatest hope. Life did not just return, it became stronger, more creative, and ready for every new challenge. Out of the silence and cold, life made a world of bright color, movement, and endless possibility. Now nothing on Earth is untouched by those first changes. Our bodies, the air, every plant and every animal all carry the memory of that time when Earth was a frozen ball, when hope was quiet, and when the only light came from those who would not give up. The story of Snowball Earth is not only about cold and ice. It is a story of waiting, lasting, and changing. It is the story of how every small thing working together can change the world in ways that last forever. As animals rose from simple beginnings, each new kind of life joined the story, and the ocean became the home of every adventure yet to come. The quiet strength learned in the snow and cold gave birth to a living world that would keep changing and growing for millions of years. From the first group of cells holding together deep under the ice to the soft-bodied animals spreading on the warm sea floor, every moment mattered. Life found a way through the hardest times and created everything that fills the earth today. The quiet time of Snowball Earth ended and a new age began, full of life's promise, stronger, more complex, and ready to shape the future in every part of the world.